Welcome back, everybody. Today, we're going to be doing a deep dive into a really important part of data clustering.
Oh.
And that is, how do we actually know if the clusters that we've created are any good?
Yeah.
Like, we've got these groups,
How do we tell?
but what makes them meaningful?
Yeah, are they real?
Exactly.
Or are we just imposing something on it?
Right. And so, to help us answer this question, we're going to be looking at something called silhouette analysis.
Very cool.
And we're going to be basing this deep dive on the Wikipedia article about this topic.
Awesome. Sounds good.
It's a really cool method because it gives us like a quantifiable way to assess the quality of our clusters.
That's right. Like you've run your algorithm, you've grouped your data, but now the question is, does it mean anything? Are those groups actually different from each other in a meaningful way? And so silhouette analysis is all about coming up with a number that helps us.
So instead of just like looking at it,
being
like, oh, those look pretty good.
Exactly.
Right.
Like instead of eyeballing it, you get an actual number. And that number is called a silhouette value.
Okay, so that's what we're aiming for.
Yes, and that number can range from -1 to +1.
Okay.
The closer it is to +1, the better that point fits into the cluster that it's assigned to.
Gotcha.
And also, the farther away it is from the other clusters.
Okay.
If the value is closer to 0, it's kind of like, it's on the border.
Okay.
And then if you get a negative value, that means it's probably closer to another cluster and it might have been misclassified.
So that's like saying this data point's more like a different friend group.
Exactly. Yeah, it's hanging out with the wrong crowd.
Yeah, it's like awkwardly at a party where it doesn't know anyone.
Exactly. That's a great analogy. And the cool thing about silhouette analysis is we can actually quantify that awkwardness.
I like that.
And then use that to evaluate our clustering as a whole.
Okay, so we've got the idea of what we're aiming for, this silhouette value.
Yeah.
How do we actually calculate that?
So there's a formula for it, but it's more intuitive than it might seem.
Okay, good.
Basically, the formula boils down to comparing two distances for each data point.
Got it.
The first distance is called A of I.
Okay.
And that's the average distance from our data point to all the other points within the same cluster.
So that's like saying how close are all the friends?
Exactly. It's like measuring the tightness of the friend group.
Yeah. Smaller A of I, the better.
Exactly. The smaller the distance, the more cohesive the group.
Perfect.
And then we have B of I, which is the smallest average distance to points in a different cluster.
Oh, so this is like...
So it's like how far away is our data point from the nearest neighboring cluster?
Okay, so we want a large B of I.
Exactly. We want that data point to be much closer to its own group than to any other.
Okay, that makes sense.
Right. And the silhouette formula captures that intuition perfectly.
Lay it on me.
It calculates the difference between those two distances, B of I minus A of I, and then divides that by the larger of the two. Okay.
So you get the silhouette value, which is S of I equals B of I minus A of I, all divided by the maximum of A of I comma B of I.
So you're like normalizing it.
Exactly. You're normalizing it by the bigger distance.
Right.
So it always falls between -1 and 1.
Got it. Okay, so that's a pretty elegant way to capture that idea of how well something fits into a group.
Right.
Now, what about the edge cases? Like, what if a cluster only has one point?
That is a fantastic question.
How do we calculate the silhouette value there?
Well, in those cases where A of I would be undefined, the silhouette value is simply set to 0.
Oh, okay.
So it's kind of like we don't have enough information to really judge how well this lone point fits, so we just call it neutral.
Gotcha. So it's like saying this data point is neither here nor there.
Exactly. It doesn't skew the overall analysis in any particular direction.
That makes sense.
Yeah.
Okay. So we've got our individual silhouette values now.
Right.
But the real power of this method is looking at the bigger picture.
How do we go from these individual data point scores to judging the quality of the whole clustering?
Right. So to do that, we use something called the average silhouette width.
Okay.
And we can calculate this for each cluster.
Gotcha.
And that gives us a sense of how tightly grouped all the points in that cluster are.
Okay. So like if all the points in a cluster have really high silhouette values, then the average silhouette width for that cluster is also going to be high.
Exactly. And that suggests that that cluster has a really strong internal cohesion.
Got it. So it's like taking the average friendliness score of everyone in the group.
I love that analogy.
If the average is high, then it's a tight-knit group.
Yes. And we can also calculate the average silhouette width for the entire data set.
Oh, okay. So like taking the average of all the A of IS.
Not quite. It's the average of all the silhouette values.
Oh, right.
So we're looking at all the points across all the clusters. And that gives us an overall measure of how well our clustering method has done in separating the data into these distinct and meaningful groups.
So that's like saying, how well did we do at dividing everyone up at the party?
Exactly. Like, are there clear groups, or is everyone just kind of mingling randomly?
Right. And a high average silhouette width for the whole data set would be a good sign.
It would mean we've done a good job.
We found the real groups.
The clusters are well-defined and well-separated.
Okay. And what if the average silhouette width is low?
Oh, that's when we start to worry.
What does that tell us?
It could mean a couple of things. Maybe our clusters are overlapping too much.
Oh, so like some people are trying to be in 2 friend groups at once.
Exactly. Or it could mean that we chose the wrong number of clusters altogether.
Oh, so like we tried to force everyone into 3 friend groups.
Yeah.
When really there were 4.
Right. Maybe there's a whole group of people we missed.
That makes sense.
So it's not just about finding clusters, it's about finding the right number of clusters.
The ones that actually reflect the natural groupings in the data.
Exactly. We want to uncover the true structure that's hidden within the data.
Gotcha. So how do we find that sweet spot?
How do we know how many clusters to choose?
Yeah.
That's where a really cool metric comes in called the silhouette coefficient.
Okay.
And the silhouette coefficient tells us the maximum average silhouette width we can achieve for a given number of clusters.
Oh, so we could calculate it for like 2 clusters, 3 clusters, 4 clusters.
Exactly.
And see which one gives us the highest coefficient.
Exactly. And that would be the optimal structure.
That's like a Goldilocks situation.
Yes. We want the number of clusters that's just right.
Not too many, not too few.
Not too many, not too few.
Perfect. Okay, so now we have a way to figure out how many clusters we need.
Right.
And then we can use our silhouette values to see how good those clusters are.
Exactly. It takes the guesswork out of clustering.
I love it. This is super useful.
Yeah.
Now, I do have a question, though, because calculating all these distances for every single data point, it seems like that could get really computationally expensive.
Absolutely, especially when you're dealing with really large data sets.
Right. So are there like any variations of the silhouette method that help us with that computational challenge?
Yes, there are a couple of variations that offer some computational advantages.
Okay.
While still retaining the core idea of measuring how good our clusters are.
Okay, good.
One of these variations is called the simplified silhouette.
Okay.
And it basically simplifies the distance calculations.
How so?
Well, instead of calculating the distances between all pairs of points, we just focus on the distance to the cluster center.
Okay.
Which is usually the mean of all the points in the cluster.
Oh, so it's like we're using a representative point for each cluster.
Exactly. Like a delegate from each friend group.
I like that.
And that really speeds things up.
Yeah, that makes...
Because instead of doing all these pairwise comparisons,
right,
we just have to compute the dissonance to this one central point.
Gotcha. And is there another variation?
Yep. There is another variation called the medoid silhouette.
Medoid.
Yeah, the medoid is kind of like the mean.
Okay.
But instead of being the average point, it's the actual data point within the cluster.
Okay.
That's closest to all the other points.
Oh, so it's like the most central point in the cluster.
Exactly. Like the person who knows everyone in the friend group.
Uh-huh. Yeah. That makes sense.
So the medoid silhouette uses that medoid as the representative point.
Okay.
Instead of the mean.
And why would we want to use the medoid instead of the mean?
So the medoid is particularly useful when you're using a clustering method called k-medoids clustering.
Okay.
Where the medoid is already inherently the central point.
Oh, so it's like built into that method.
Exactly. It's like the medoid is the natural representative for k-medoids.
Got it. So the choice of which variation to use depends on the clustering method and the size of our data.
Precisely.
Okay.
That makes sense. You wouldn't want to use the medoid if your clustering method doesn't actually produce medoids.
Right. That would be weird.
Exactly. You got to pick the right tool for the job.
So it seems like the silhouette method in all its forms is like an essential tool.
Absolutely.
For anyone who's working with cluster analysis.
It's like the magnifying glass for clustering.
I like that.
It helps you see the details and make sure your clusters are actually meaningful.
And it gives us a way to quantify the quality of those clusters.
Exactly. Instead of just relying on our intuition or visual inspection, we have a number that we can use.
Right. And that helps us make decisions.
Absolutely. Like how many clusters should we choose? Or how well does this particular clustering method work for our data?
Exactly. And what's really cool is that this silhouette method isn't limited to just these like traditional clustering tasks.
You're right.
Like we've been talking about grouping similar data points.
Yeah.
But there's so much more it can do.
Absolutely. Its potential applications extend far beyond that.
Like what?
Well, for example, we can use the silhouette method for anomaly detection.
Anomaly detection.
Yeah. So imagine you have a bunch of data points, and most of them fit nicely into their clusters.
Yeah.
But then you have a few data points that have really low silhouette values.
So they're like the awkward party guests.
Exactly. They're not really fitting in anywhere.
Okay.
And those data points could be flagged as potential anomalies?
Oh, so it's like the silhouette method can act as an outlier detector.
Precisely.
It can help us find the data points that are really different from the norm.
Exactly. And that can be incredibly valuable in many different domains.
Like what? Give me an example.
Think about image segmentation, where you want to partition an image into meaningful regions.
Okay.
The silhouette method could be used to group pixels together based on their similarity.
Oh, okay.
And then you could use those groupings to segment the image.
So it's like using the silhouette method to find the boundaries between different objects in an image.
Exactly. You're basically clustering the pixels.
Wow, that's amazing.
It's really cool how this one concept of quantifying how well things fit into groups
Can be applied in so many different ways.
It's like a universal tool for finding patterns.
It is. It's all about finding the hidden structure within the data.
Awesome. So we've talked about clustering, we've talked about anomaly detection, even image segmentation.
What else can we do with it?
What else can we do with it? That's the question I want to leave our listeners with today.
Yeah, so many possibilities, right? Like we've seen how silhouette analysis helps us judge those clusters, see if they're good or not. But can we push it even further? I mean, image segmentation, that's cool, but what other, like, unusual ways could we use this?
Ooh, yeah. I like where you're going with this, like thinking outside the box.
Yeah, exactly. Like, could we use silhouette analysis for something like social networks? You know, grouping people together based on, like, who they're connected to and how they interact.
Oh, that's a really interesting idea. In social network analysis, right, we're always trying to find those communities, those clusters of people who share similar interests or connections.
Right.
And I think silhouette analysis could totally help us there. Like, imagine we have a bunch of different algorithms for detecting communities in a network.
Yeah.
We could use silhouette analysis to compare them and see which one produces the most cohesive and well-separated groupings.
So it's like we're not just looking at the network and being like, oh, yeah, those groups look good.
Exactly. We're actually getting a concrete measure of how well those communities reflect the real underlying social dynamics.
I like it. So instead of just eyeballing it, we've got some hard evidence.
Exactly. And that could be super valuable for understanding all sorts of things, like how information spreads in a network.
Oh, yeah.
Or how opinions form, or even how social movements gain momentum.
Wow, the possibilities are endless. It's like we're using math to unlock the secrets of society.
It is. It's all about finding the hidden structures and patterns in the data.
So we've gone from clustering data points to analyzing social networks.
Yeah.
What other crazy applications can we think of?
Let's see. Oh, what about financial markets? Like, imagine you want to group stocks together that have similar performance patterns. Okay. Silhouette analysis could totally help us evaluate different clustering methods and see which ones do the best job of capturing the market structure.
So it's like we're trying to find the groups of stocks that move together.
Exactly. Like, are there certain sectors or industries where the stocks tend to behave in similar ways?
And then we can use that information to make better investment decisions.
Right. You could use it to diversify your portfolio or identify potential trading opportunities.
Wow. So silhouette analysis is like the ultimate pattern recognition tool.
It really is. It helps us uncover those hidden connections in the data, whether it's data points or people or even stocks.
It's amazing to think that one method can have so many applications.
Yeah, it just goes to show that the power of math and statistics goes far beyond just crunching numbers.
It's about understanding the world around us.
Absolutely. And finding those insights that would otherwise remain hidden.
I love it. Well, I think our deep dive into the silhouette method has been super insightful.
Yeah, we've covered a lot of ground.
We've seen how it works, how to calculate it, and even some of its crazy applications.
From clustering to anomaly detection to social networks and beyond.
But before we wrap up, I want to leave our listeners with a final thought.
Ooh, I like it. What's the challenge?
So we've seen how silhouette analysis can help us check how good our clusters are and even find those outliers. But could we use this method in even more like out there ways? We talked about image segmentation, but what other areas could benefit from this approach? Could we maybe use silhouette analysis to like analyze social networks, grouping people based on their connections and how they interact.
That's a super interesting thought. In social network analysis, we're often interested in finding communities or clusters of people who share similar interests or connections.
Right.
The silhouette method could potentially help us evaluate different algorithms for finding those communities and see which ones create the most tightly knit and well-separated groups.
So instead of just looking at the network and saying, oh, those groups look good, we could actually use silhouette analysis to get a number to measure how well those communities reflect the real social dynamics going on.
Exactly. It's like adding a layer of quantitative rigor to our analysis. And this could be really valuable for understanding all sorts of things, like how information spreads in a network, how opinions are formed, or even how social movements gain traction.
It's like using math to uncover the secrets of society. So we've gone from clustering data points to analyzing social networks. What other unexpected applications can we come up with?
Let's see. Oh, what about financial markets? Imagine we want to group stocks together that have similar performance patterns.
Okay.
Silhouette analysis could help us evaluate different clustering approaches and find the ones that do the best job of capturing the underlying market structure.
So it's like we're trying to find those groups of stocks that tend to move together.
Exactly. Like, are there certain sectors or industries where stocks tend to behave similarly? And then we can use that info to maybe make smarter investment decisions.
That's fascinating. It seems like there's no end to the potential applications of silhouette analysis. It goes way beyond its typical use in clustering.
The key takeaway here is that this silhouette method gives us a way to measure how well things fit together in groups, how coherent those groups are, and the relationship between individual data points and the groups they belong to. Its potential uses extend far beyond those traditional clustering scenarios. The challenge and the excitement is in exploring those uncharted areas, adapting the method to new contexts, and uncovering those hidden structures within all sorts of data sets.
It really feels like we've only just begun to explore the possibilities of the silhouette method. There's a whole universe of potential applications just waiting to be discovered.
Exactly. And as with any powerful tool, it's super important to understand its strengths and limitations. While silhouette analysis offers valuable insights, it's not a magic solution that fits every situation.
Okay.
The way we measure distance, the kind of data we're working with, and the specific goals of our analysis all matter in determining how effective it will be.
That's a great point. So to wrap up this deep dive, we encourage you, our listeners, to think outside the box when it comes to silhouette analysis. Push those boundaries, explore new areas, and see where this awesome tool can take you.
The world of data is huge and complex. Embrace the power of analytical tools like Silhouette, but always approach them with a curious and critical mind.
Thank you for joining us on this deep dive into the silhouette method. We hope you've learned something new today, and even more importantly, that we've sparked your curiosity to explore its potential even further.